Okay, so let's take a look at this. 3.5 quadratic function model solving quadratic equations. So in order to solve a quadratic equation, as you see in example 1 here, 4x squared minus 12x plus 9 equals 0. Remember, this is an equation, it equals 0. What are you trying to find? If you recall, a quadratic formula that is in not vertex form or factor form, but standard form, ax squared plus bx plus c. If it equals 0, when y equals 0, that is finding the x-intercepts. So when you're solving these things, you're finding the x-intercepts where the parabola crosses the x-axis. Now, it's very important you understand that the parabola may look something like this, where it crosses, and I'll just talk about parabolas that open up for now, but a parabola may look like this, and the parabola may cross twice. Okay, that's one option, and that's usually what we've been used to. But you may have a scenario that looks like this, where the vertex is up here, and the parabola opens up, and it never touches the x-axis, so you never get an answer. So it's impossible to solve it. Or you may end up with something like this, where you have the vertex right on the x-axis, and it only crosses the x-axis once then. And if it only crosses once, you know that it crosses only at the vertex. Okay? So you have three different scenarios. You may cross twice, you may end up with two answers. You may cross once, one answer, so the vertex is on the x-axis. Or you may never cross, so the vertex is above and it opens up. These are just opening up parabolas. Obviously, you can make the same argument for parabolas that open down. So let's take a look at what I'm saying here. It says solving a quadratic equation means finding the x-intercepts or roots or zeros. Okay, so x-intercepts, roots, zeros, or solutions, they all mean the same thing, where they cross the x-axis. And you're finding this solutions, or x-intercepts, or roots, or zeros of the function. There are a few ways to solve when the quadratic equation is in this form, and this form is standard form. Well, number one would be graphing. Now, graphing, not the best way, especially when you may not cross you may cross the x-axis at a number that is not a whole number. How do you figure out that the x-intercept is exactly 2.17437? You wouldn't be able to calculate that. So graphing is probably the worst way unless you have a graphing calculator. Then you have using the quadratic formula. Quadratic formula will give you the solution always. Now, it's very important to note that in the quadratic formula you have a radical, and we know how to deal with radicals from 3.4 and how to reduce radicals properly. So no longer are we going to, write down the square root of 2 is 1.41 and approximate it. We're going to write root 2, and we're going to deal with it in that manner. So we're not going to use approximate solutions unless it specifically asks us to round to a certain digit. And then there's, of course, factoring. Factoring is a good way of solving or finding the x-intercepts if the thing is factorable. Sometimes it is not factorable, so you don't want to, if you can't factor it, doesn't mean it's not possible, it just means it's not factorable, so you're not going to get nice answers. It could mean it's impossible, but it doesn't necessarily mean it's impossible. If you can't factor, automatically you try the quadratic formula, and only if the quadratic formula doesn't work for some reason, then it is impossible. So we'll get to that. So example 1, solve by factoring. So we're going to solve this using factoring. So if it's asking me to solve using factoring, it should be factorable. So if I take a look at this, I'm going to go factor this thing, but before I started factoring this thing, I noticed that this is a complex trinomial. There is no common factor between these three digits. So I would have to use decomposition or the crisscross method, but I'm not going to use either because I think that this may be a perfect square trinomial. See, I noticed that the square root, I take the square root of that and that. The square root of this is 2x and the square root of this is 3. If I do 2 times 3, it's 6x, double it, it's 12x. So guess what? This is a perfect square trinomial. So I actually don't have to use crisscross method or decomposition, but if you used crisscross method or decomposition, you would end up with this. Perfect square trinomial comes from a binomial squared. The square root of that is 2x, the square root of that is 3 with the negative sign in the middle. So in reality, you have two of these brackets, 2x minus 3 sorry, 2x minus 3 times another 2x minus 3. If you went to go factor using decomposition or crisscross method, that's what you'd end up with. Two of the same x-intercepts, actually, right? Because these give us our x-intercepts. Now, how do I find my x-intercepts from here? We have to find what makes this bracket 0 or what makes this bracket 0. Well, what makes this bracket 0? What makes 2x minus 3 0? Well, if I solve this, this is going to be 2x is equal to, bring this to the other side, 3. Divide both sides by 2, and so I'm going to get x equals 1.5 or 3 halves. Now, 1.5 is okay to write. 3 halves is okay to write, either one. But if it was a third, please don't go write 0.3 with a bar on top, because that's improper format. You would write 1 over 3. So you get one of my x-intercepts is 3 halves, and guess what? If you did the other one, it's going to give the exact same answer, 3 halves. So you have one root. Actually, what they call it is one double root, because there are two of the same root, or two of the same x-intercept. If there's only one x-intercept, what does that mean? Well, it means that at this number, 1.5, so here's 1, here's 2, at that number 1.5, there's only one x-intercept. This opens up because the a value is 4. So guess what? All that means is that the vertex is the x-intercept. So if you actually graph that, that's what it would look like, something like this. So there's only one answer, and the answer is 3 halves, or 1.5. Okay, so let's take a look at question B. In question B, same thing. It asks us to solve using factoring. Now this is just a simple trinomial. So if I go to factor this simple trinomial, I'm just going to use PSI. No need to use decomposition or crisscross method. PSI, the product of this thing is negative 40. The sum of this thing is 3. So I'm looking for two numbers that multiply to 40 and add to 3. Just remember, if you're ever stuck, to give me the factors of 40. There's 1 times 40, there's 2 times 20. Obviously, you're going to have to be a lot closer. There's 3 times nothing, there's 4 times 10. You know, there's 5 times 8, there's 6 times nothing, 7 times nothing. This is it. The only thing that would have a chance of adding to 3 is that. Remember, they have to multiply to a negative number, so the two numbers are negative 5 and positive 8. That times that is that plus that is that. So the two factors would be, one of the factors would be x minus 5, one of the factors would be x minus 8, x plus 8. Just remember, it doesn't mean the two answers are negative 5 and 8. Those are the two factors. So it's very important you understand that. Now, when you go to solve this, just remember, solving this bracket times this bracket equals 0. That means either the number in here is equal to 0, or the number in here is equal to 0. 0 product property from grade 10, right? Some bracket times some bracket equals 0, so that means either something in here is 0 or something in here is 0. That's the only way you'll be able to multiply to be 0. And so if this bracket is 0, if x minus 5 equals 0, that just means x equals positive 5. That's one of your answers. And if x plus 8 is equal to 0, that just means x equals negative 8, bringing the 8 to the other side. Some of you may just be able to look at that, okay, x equals 5 makes that bracket 0. So I'm okay with that. You don't have to show this step. But these are the two answers. 5 and negative 8 are your two solutions. So it crosses at 5 and it crosses at 8. If you gave yourself a little picture, if you were to draw this for yourself very quickly, what this is saying is that one of my x-intercepts are 1, 2, 3, 4, 5, and 1, 2, 3, 4, 5, 6, 7, 8. I can figure out what this looks like, because here is my one x-intercept of negative 8. Here is my one x-intercept, my other x-intercept of 5. And of course, I can find the vertex, because I know that the vertex is right in the middle between these 2 points. Now, this is going a little bit above of what we're doing, but how do you find the middle between two numbers? You can either count to the middle or add them together. If you add both together, negative 8 plus 5 is negative 3, and cut it in half. So it's actually negative 1.5. So this is the middle, negative 1.5. X equals negative 1.5. What would I do to find the vertex? I know the vertex is on this line, so I would just plug in x equals negative 1.5 into this and figure out what that number is. And that would be my the height of my vertex. Obviously, the vertex is going to be somewhere down here because it opens up, because the number in front of x is 1. But that's just a little bit above and beyond of what we're doing here. Right now, we're just looking for the x-intercepts. unless they ask us for more. So let's take a look at this one. Solve using the quadratic formula. So let's say it asks me to solve this. If it specifically asks me quadratic formula, you have to use quadratic formula. Specifically asks factoring, have to use factoring. If it just says solve, well, you have the option. I always check to see if it's factorable first because I like factoring. I hate using the quadratic formula. Mind you, not everything's factorable. So if I take a look at this, again, to use the quadratic formula, you have to know what the quadratic formula is. So my suggestion is learn the quadratic formula. It's negative b plus or minus the square root of b squared minus 4ac all over 2a. Now what's your a, b, and c? Remember, your a is the number in front of the x squared, which is 4. Your b is the number in front of the x, which is negative 12. And your c is the constant at the end, which is positive 5. So sometimes I like to write that off to the side. A is 4, b is negative 12, and c is 5. And I'm going to plug that in here. So plugging that in here, that means x is equal to, and this gives me the solutions right away. So x is equal to negative b, so be careful, negative, and then b is negative 12, plus or minus the square root of b, which is negative 12, all squared, minus 4 times a, which is 4, times c, which is 5, all over 2 times a, which is 4. So x is equal to, a negative and a negative become a plus 12, plus or minus the square root of negative 12 squared is 144, and this is negative 4 times 5, that is 80. So negative 80, and all over 2 times 4, which is 8. Continuing this is x equals 12, plus or minus the square root of, and when I do this, 144 minus 80, that is 64, I believe. Yes, 64. Let me just double check that. Yes, 64. So continuing this, all over 8. Now, it's actually very nice that you ended up with a 64 under here. Sometimes it's not so nice. You could actually take the square root of 64. So when I continue this, apologize for using up here, but it would end up being x is equal to 12 plus or minus the square root of, actually the square root, I don't have to do that anymore. Breaking down the square root of 64, again the square root of 64 is just 8, all over 8. So this ends up being 2 answers from here. I have x equals 12 plus 8 all over 8, or I have x equals 12 minus 8 all over 8. Continuing this, 12 plus 8 is 20, so you're going to have 20 all over 8, and I can reduce that. 20 over 8, both are divisible by 4, so this is going to be 5 halves, so 2.5. And over here, x equals 20 minus 8 is negative 4 all over 8. So this ends, sorry, not negative 4, positive 4 all over 8. So positive 4 over 8 is just a half, so 0.5. Now, what this means is, if you could actually take the square root of that number, you would have been able to factor this from the start. Now, I know that it asks us to use quadratic formula, so you have no choice. But whenever you end up with this, where the underneath the square root sign is a whole number that you can take the square root of, you would have been able to factor this from the start. Not all the numbers that are under the square root end up being a nice number. Sometimes the number under the square root is 50. Well, if it's 50, you can't take the square root of 50. The square root of 50 is approximately 7.1, but you're not going to write 7.1 approximate, you're going to write the real answer. So you would have to apply last section 3.4 and break up the square root of 50 to root 25 times root 2. So we'll get to that.